Want me to stop? I think we're going.
Go for it.
Hi! Welcome to the Harkin and Henning Show. Mrs. Henning is on her way.
Getting my goggles.
Getting our goggles.
Safety goggles on.
Gotta be safe.
Yes.
Because we're twinning today. Look.
Woo!
Yeah.
We're so awesome.
Yeah. Oh, I didn't put mine on my eyes.
Okay,
Okay, there we go.
Yeah. Okay, I think we left off. We had a little pause in there.
Yep.
So we left off just talking about how this problem here, this example problem of 50 grams of 90-degree metal into 50 grams of 30-degree water after 10 minutes, what will the temperature be?
Ooh.
That's actually a big, long equation.
Ooh.
And it basically is saying that the water, that 90-degree water, is going to transfer some of its energy into that 30-degree water.
Right.
Yeah, and they actually, we're not going to learn that equation, but the idea is that that heat energy is moving from the hot water to the cool water.
Yep.
All right. The biggest thing I think we want you to get, you don't have to write anything from that. The biggest thing we want you to get is in this phase changes,
Yes.
we don't have anything new.
No, it's water. So if you think about water, it's
Yeah.
water is water. It's always water.
Yeah. So when you have an ice cube, it's water.
Yes.
It's still a compound. It has that H2O formula. And then we're going to add energy to it,
Ooh, and then it's going to turn into water, a liquid.
a liquid. And it's still water.
It's still water.
It's still H2O.
Yep.
And then sometimes if we're making macaroni and cheese,
Oh, I like that.
yeah, we boil it.
Yep.
We add more heat energy to it.
Takes a lot of heat to boil that water.
And then it evaporates. And now I have water in the air.
Yes. Still water.
Still water.
It's just in the air.
Yeah. So that would be a good thing to write down. Changing your state of matter doesn't change the composition or what's in that stuff. It's just a physical change. So, and then you don't have to write that down, but that's the example that we just talked about there. It's a physical change.
Yes.
I don't have anything new. I still
No.
have water. It's just a different state of matter. Phase changes are reversible.
So I can go from water to ice and then ice to water. So you can go either direction.
Yep. Beautiful.
Yay.
Oh, this is a graph I definitely want my students to copy down.
Mine too. This is super important.
Yep. This is just simply representing how anything that's a solid, when you add energy, so if you look at the x-axis there, down here at the bottom, you're going to know we're going to travel from left to right. And that means we just keep putting more and more energy on. So if we had our Bunsen burner would be on this whole entire time. So that never, according to this graph, we never turn that Bunsen burner off.
Nope.
And then as you go from bottom to top there, you see our temperature increases. So one of the weird things about states of matter is that we still have the heat on this whole time, but for some reason our temperature doesn't change for a while here, even though this still has, you can see our energy is still going left to right, our heat is still on. What that energy is doing though is actually changing my object's state of matter.
And that takes a lot of energy.
It takes a lot of energy, so I can't change my temperature because all the energy is going into
Changing that state of matter.
changing that state of matter. You're going to see I have two flat areas here. This one, right here at this exact point, we would say, oh, that's my melting
My
point.
melting point.
Right there, and I usually have my kids actually put that little dot on there.
Let's do that. Let's put a little dot there and label that melting
Point. And you can see my melting point, so that temperature stays the same. Sometimes it's a long time, sometimes it's a very short amount of time.
It's going to depend on what material you're trying to melt.
And then I get all melted, so down here at the end, right here, now this is this is all, I'm half and half. Half solid, half liquid.
Half ice, half water.
Yes.
Yes.
It's that melting process. When I get to the end of that straight line, I'm all melted.
So it'd be liquid.
Yes, all liquid. And then I'm all liquid, so now my temperature starts to increase as I'm a liquid because I still have my energy on down here at the bottom, and I just keep getting hotter and hotter until I reach this point up here, which says, oh, I have now reached that temperature we would call boiling temperature or boiling point, where I'm going to change into a gas.
Just like when you're making your macaroni and cheese and
Mm-hmm.
you put your water on, it takes a long time for it to boil, and you have to keep adding heat energy in on your stove in order to get to that boiling point.
Yeah, and what's really crazy, this is boiling this whole entire time,
Ooh.
but it stops. Even though my stove or my Bunsen burner is still on, my temperature stays the same because all that energy is breaking up those molecules of water,
and they're starting to...
to get small enough to be a gas. So that flat line again is at that point where I'm half liquid, I'm half gas.
Yes.
Half and half. And then, of course, we get to the end where I have evaporated all of my water, kind of like what you guys saw with your mixture lab.
Ooh.
You evaporated all your water, and now it's all gas. And then you'll see that gas. If we could hold that gas in the container, it would also increase and increase. And we get to a point where, I don't know what it's called, but we would start changing into a plasma. But we don't have anything that high.
We can't do that here.
So that's the idea behind a phase change graph. Now what you're going to be able to do is actually use a material, and you're going to add some heat energy to it, and you're going to graph how that changes from a solid to a liquid, and from a liquid to a solid. We actually go back.
Ooh,
We're going to do the
and
reverse.
forth. Yay.
So
Make sure you have that drawn in your lab notebook.
otherwise it'll just be confusing.
Yep.
That's the end.
Yay.
Thanks, guys.
Bye.